2 to the t. Is that right? Look at Perel process. Perel doesn't like it. That's right? All right. Now I could, by the way, clean this up if I wanted to. I got a 2 and a 2. I could write this as t, 2 to the t plus 1, couldn't I? That's one of the reasons I like it, because they monkey with that sometimes. It's a little annoying. Yes, sir.
If you split the integral, like its multiplication side and your addition outside, this is the
yeah.
Very much. Are there 2 plus c's?
Yes, but what's c plus c?
2c?
No. C plus c is c. C can be any number, right?
Yeah.
So a c plus a c is just another c.
Alright.
The c divided by c is also c. C times c is c. Yes?
Can you solve 45 doing like chain numbers?
Doing Cheney rules? All right, I'll try 45 doing Cheney rules. 45 doing Cheney rules. Cheney rules. Okay, so it's going to be 1 over ln of 5, right? Times the inside, which is the square root of x squared minus 1. Times, okay, so now I've got, that's the 1/2 power, so I got to do 1/2 x squared minus 1 to the negative 1/2 times 2x.
So if I just do this way,
You're going to get the same answer. It just takes a lot longer to simplify that.
Actually, it's not that nice.
Right, oh, yeah, it worked. So I've got a 2 here and a 2 here, right? So those go away. I've got this, the 1/2 power should be on the bottom, so multiply with the square root, same exact square root on the bottom, right? So I get 1 over ln of 5 times the square root of, no, square root goes away, so I just squared it. Multiply by itself, right? X squared minus 1, there should be an x left over on top because there's an x sitting here. That's the answer. Now, the good news about calculus is you can do a lot of things. It's not a you have to do it this way sort of thing. A lot of places. All right. Obvious simplification steps. If I was grading that, I would get rid of 2's. Yes, I would have to argue you'd have to get rid of 2's because otherwise that's bad. Would I, if I had a magic wand, say you'd have to deal with the fact you've got a negative square root up here and a square root on the bottom, then you should probably put those together. I would think, did you want to do that? I'll tell you this, on the multiple choice, the answer is going to look like this, right? So you'd have to be able to get to there. In the free response section, they might let you keep that. They might even make you get rid of those halves, which would be really bad. But the problem is the definition of obvious simplification tests might be problematic in this case. I'll tell you, some problems they don't even put on the AP test simply because they're not sure what the obvious simplification step would be or not be, so they don't want it on the test. So something like this, they might say, you know what, let's just not put it on the test, or put in the multiple choice where they give you one of the choices for the answer. Or should that up?
Can you do it the long way? Like, can you just go through that?
What long way?
The log way, the 45.
45. There is not a nice. I mean, I did it the long way. The only thing you can get advantage as that's 1/2 power means I can throw it out front. Other than that, it's a minus sign. That's not anything. I can't take it apart. So I'm stuck just doing it and tacking on the chain. Right? There's no cute. I mean, there's no multiplication. There's nothing to get out of there. I mean, I guess if I was really trying to be cutesy, I could make this an x plus 1 and x minus 1 times each other, and then I could separate it with a plus, but no. I don't think that's saving anything. So I've got an integral of x5 to negative x squared dx. And that's 63, right?
Yeah.
Okay, so what's ugly? I mean negative x squared, right? U equals negative x squared, so du equals negative 2 dx, right? I need negative 2 dx. I've got the x I need, so I'm feeling okay about this. So I've got my integral, I got my x dx, I got my 5 to negative x squared ready to go. I'm going to tack it at negative 2 here, so I'm going to put a negative 1/2 out in front. So now I'm going to go ahead, everything's ready to be U'd, so I'm going to U it. Right. And then that's going to be 1 over negative 1 over 2 ln of 5. 5 to the u plus c. Is that right? Okay. And 1 over 2 ln of 5. 5 to the negative x squared plus c. I think that's it.
I was just so used to logs that I split up the variable from the start.
You cheater.
And then I couldn't figure out how to do it because then.
Yeah, that would make it, then you'd have a use substitution you couldn't do.
Yeah.
You wouldn't have the x available. Is that good?